Good afternoon, everyone. So thank you again for joining us at the transport stage. Thank you for sticking with us if you've been with us all morning. If you're new to us, thank you very much for joining us. I won't ask where you've been. I'm Paul Gadd. I'm from Innovate UK, and we're just going to take a quick overview of what we've seen so far and then introduce the panel. So we've had a brilliant session looking at the total vision of the future of transport, and then started to touch on the place and how we adjust our transport systems to fit to the place and the circumstances that are there. But when we think about the transport system, we do often focus on the tailpipe, but we also need to think about how the embedded emissions within our transport systems, within the vehicles, within the infrastructure. And there's actually quite a lot of embedded emissions in there. So if we're to reach net zero, we are going to have to adjust the production systems that we use in order to deliver lower carbon products, lower carbon infrastructure, and we're also going to have to consider the recyclability and reusability of assets to give ourselves a longer life. So there's a lot of challenges within that, but there's also, at the same time, sweeping through our manufacturing systems, our production systems, other changes. So in terms of increased resilience needs and increased needs around, or increased opportunities around digitalization and technology. So lots of changes going on, lots of opportunity, and therefore a really exciting area to explore with our expert panel. I will remember this time, there is a Slido screen up on the side. If you want to ask questions to the panel, please do log into that and they will be fed through. But other than that, we're going to dig into this, and I'd like to please introduce Dr. Wolfgang Schuster, who's an Executive Director at the Connected Places Catapult. Wolfgang.
Great. Can you all hear me all okay? Brilliant, thank you. Very good afternoon all, and welcome to this session on decarbonizing the supply chain of transport. As Paul was saying, my name is Wolfgang Schuster, and I'm Executive Director. That's our rebranded CTO position at the Connected Places Catapult. For those of you who are not familiar with the Connected Places Catapult, we are the UK's innovation accelerator for cities, transport and place leadership. We're focused on providing impartial innovation as a service to infrastructure providers, public bodies and businesses, really with a goal of catalyzing step change improvements in the way people live, work and travel. And we're focused on driving economic growth, spreading prosperity and also crucially eliminating carbon. We're very privileged to have a very illustrious panel this afternoon. And I'd like to start really by asking each one of you to introduce yourselves and briefly tell us, why are you here today? Maybe I can start with you, Philippa.
Good afternoon, everybody. I'm Philippa Oldham. I'm Stakeholder Engagement Director at the Advanced Propulsion Centre. The Advanced Propulsion Centre was founded in 2013 as a joint industry government organisation to support the automotive sector transition towards what was then low carbon but now net zero to develop the vehicles. So that's supporting both research and development to lead and grow into that industrialisation capacity. And then later we now facilitate the Automotive Transformation Fund. So that's investment in capital facilities to really anchor and grow the supply chain here in the UK. So far we've supported investment of 1.3 billion in the sector over that 10-year period, created and safeguarded 55,000 jobs and saved over 350,000 tonnes of CO2. So some good metrics there. So for myself, you know, why am I here today? We're here today as the Advanced Propulsion Centre because it's about joining those dots. It's about how do we transition as a sector, but recognizing that it's not just an automotive sector. We also need to interconnect what's happening with infrastructure, what's happening with energy, and looking at the whole system. And that's a really important aspect of why I'm here. And also, how can we bring more of those players into our competitions going forward and deliver more funding to your organisations to help with that transition to net zero?
Thank you, Philippa. Thomas.
Yeah, my name is Thomas Becker. Good afternoon. I'm from Munich and I'm responsible for the sustainability at BMW. And two of our brands are British, and Mini and Rolls-Royce are rapidly electrifying. And that means that very soon we are going to have more embedded carbon in the parts that we put together than we are going to have on the street. And that means that decarbonizing the supply chain becomes essential to achieving our contribution to the Paris objectives.
Great, thank you, Thomas. Chris?
Yeah, Chris Allen, Managing Director of LEVC. So we manufacture the electric black cabs. Hopefully some of you will have arrived today in the electric one, not our old diesel. I would always encourage everyone to wave the diesel ones past and go electric. But for us, electrification has been everything we've been trying to deliver since 2016, 2017, where we introduced the activity for the new black cab as a transitionary technology to support electrification, clean air zones, and adoption as part of the public need for transport within cities that's accessible. And going forward, for me, everything about our future product, our next activity, our next stage of development is about transitioning to the full BEV program and looking at the whole circular economy that sits around what is an electric vehicle and goes into it, not just the tailpipe emissions, but the entire supply chain, everything about the user experience and the energy that we use to power those vehicles.
Thank you, Chris. Rohitesh?
Hi everyone, Rohitesh Dhawan. I'm the Chief Executive of ICMM. ICMM is the body that represents the world's largest mining companies, about a third of the industry, and our commitment to producing those metals and minerals that are essential to all of our lives, but particularly to cars that we all enjoy responsibly and sustainably. So we've committed that all the metals and minerals that an ICMM member produces will be net zero by 2050 for scope 1 and 2. And of course, we are committed to working with our downstream customers to reduce our own scope 3 emissions. And the reason I'm here, Wolfgang, is of course to share with you what we're doing on the mining side of the value chain, which perhaps wasn't always obvious to you for why that matters. But in fact, every car was born in a mine. It is really a hunk of metal and mineral. And so we're certainly committed to producing that as responsibly as possible.
Great. Thank you, Rohitesh. So to set the scene, I'd like to start by exploring possible supply chain scenarios, looking at enhanced manufacturing processes, materials innovation, cleaner energy. What do you see as the key challenges in decarbonization of the transport supply chain? And are there any key blockers that you foresee? Maybe if we can start with you, Rohitesh.
Sure. I'll pick just one. Cars use a lot of steel. To produce steel generates a lot of CO2, and decarbonizing steel production is very, very challenging. Just to give you some numbers, there are 1.5 billion cars in the world. We have 32 million cars here in the UK. Now, all the steel that's produced, not just for cars, but globally, generates about 3 billion tons of CO2. Now, that's a big number, so let me just put that into context. If we as the miners who produce iron ore, that's combined with coal to produce steel, if we went to zero emissions tomorrow, we would reduce emissions by 70 million tons, 7-0. It's a lot, but compare 70 million to 3 billion, and you get a sense of why steel matters so much to decarbonizing cars. Now, we have a role to play in when we produce iron ore, but steel's the big question. So, Wolfgang, we had two choices. We could say, haha, not our problem, we've done our job, good luck, car companies, enjoy talking to the steel makers and get them to reduce emissions. That's not the route we've chosen. We've said, what can we do as miners to help the steel makers reduce emissions so that the car makers have less emissions embedded? Now, one example, when we produce higher quality iron ore, it can reduce the emissions in steel production by up to 25%. So about a quarter of that 3 billion tons could be wiped out if we continue to produce higher quality iron ore. So that's the kind of step that we are looking to take to move to higher quality iron ore. Steel production emissions go down, car emissions go down.
Thank you, Rohitesh. So really starting at that very early stages of the supply chain. And what do you see, and perhaps I move on to Thomas, what do you see as being some of the key challenges in achieving decarbonization? Do you see a specific blocker?
Well, I mean, this is a multifaceted topic. I mean, a car is made only of highly energy-intense material. Steel, aluminum, plastic, and battery cell stuff. So for all those four groups of materials, you have two approaches how to get the carbon out of the balance sheet. One is replacing the energy that powers the process. So having green electricity instead of gray electricity in the case of aluminum processing. Or replacing blast oven furnace processes in the steel industry by electric arc furnaces, or as a next step, use hydrogen direct reduction. Yeah. The other approach is using secondary instead of primary material. So therefore saving the big energy intense first steps of the process.
Yeah.
And these two basic approaches, they compete. They compete for the euro we can spend once. So that means that we need to permanently keep optimizing the combination of approaches and when to take which steps. And that's why we optimize our strategy according to the CO2 savings potential in relation to its price sticker. And fortunately, what we have been seeing over the last years is lots of innovation, lots of competition for bringing down the footprint in each of these materials. So that's good. And at the end of the day, it's about us being able to demonstrate this is the CO2 that actually went down and have really the, if you like, the aggregated CO2 sticker from the iron ore extraction to the component that goes into our cars.
Great, thank you. Philippa, do you foresee any key challenges around the decarbonisation of the supply chain?
Yeah, I mean, the gentlemen have already said, about, the challenges with the creation of materials, but, one of the big areas, and we've seen recently, is, access to those materials, and that's a big challenge. But just on the, we've touched on steel, we've touched on, but we've got a project and our role is funding. And one of the projects we have is a project called Recovers. And that is actually involving the OEMs, the battery manufacturers, and then the refurb guys, because actually we need to look at the whole system. Yeah. And that's, again, an evolution in the way that we think. Where are the materials coming from? How are we processing them? How much energy is it taking to process them? How can we optimize that manufacturing system? So looking at that, what's happening to the waste? I mean, if we see any new gigafactories being built, we expect when they first start up, there being about 20% waste initially. Which, after running for a while, that goes down to about 5%. But that's a key aspect. So how do you improve that efficiency of that process and look at the energy consumption? So again, using green energy to do that processing. But then also, once the batteries are produced, what do you do after their life? Once they've been in service, what are we doing in terms of looking at refurbishment, recovery, recycling? And so actually, we've got a number of those different partners on this project and trying to understand how they shift their models. And the reason that I just bring that up is because it's a shift we've seen in our funding mechanisms, where we've got multiple OEMs working together to really try and understand this big picture. And that's a real change in terms of the collaboration we've seen over the last 5 years, because it's a problem for everybody, and everybody needs to get as much information as they can at any start time.
Great. Thank you, Philippa. Moving on to Chris. Obviously, you wield a significant amount of influence also through procurement strategies. And what are you doing in terms of reducing the embedded carbon within those procurement processes? What decisions can you make to really help?
Yeah, I mean, it's the idea of decarbonising and looking at sustainable supply chain starts very early on in an automotive life cycle. From when we set our platform strategies that are looking 15, 20 years ahead in what we're delivering, to all of the vehicle programs that then build on that are typically 5-7 years in advance. So that early stage activity and partnering with not just the supply chain, but also with the regulators, the government, industry specialists, to really set the standards, understand what's achievable, and to work towards difficult targets. When we think about the introduction of the full electric sort of battery solution for us, it's not just about where are those battery manufacturing plants going to be located, and how do we sort of identify the best sourcing strategy, the best pricing efficiency, as well as the best technology, but it's also about how we get the right carbon input within that. And it's understanding the raw minerals that are going into that, because where we are at the moment, the industrial metals that support traditional OEMs are very established and produced in high quantities. The lithium, the cobalt, the nickel activities are sort of maturing, and they have a longer life cycle than ours in the way that they operate. And so for me, the biggest challenge and that I'm sort of seeing is that maturing of all of these supply chains right down to the tier 4 activity to be in a position to support a truly decarbonised supply chain in an environment that is encouraging of that investment to deliver those solutions close to home. Otherwise, we have to provide the products against the targets, and the industry is developing, so it creates its own challenge there.
Indeed. Building up on a point that you made, Thomas, in terms of potentially also, using second-hand materials, does the circular economy present an existential threat? And that's obviously addressed to you, Rohitesh, to mining. And how does the industry stay relevant in a world where you really have minimal virgin resource extraction requirements?
Look, the circular economy is not a threat to the mining industry. I want to be completely clear with you. We as miners are not plotting ways to stop the world from going circular just so you have to buy more copper and iron ore and other commodities. Because frankly, if we're true to our commitment that we want to produce metals responsibly, surely the most responsible type of metal is one that's already been produced rather than one that has to be produced. So I want to be crystal clear on our commitment to maximize circularity in the global economy. But Wolfgang, here's where the difficulty comes in, and it's hard for people to imagine the scale of the increase in demand for commodities we're talking about. Let me take the example of copper, which is used in cars widely. And just in case you were wondering how much copper, if you drive a petrol or diesel car, show of hands, who drives a petrol or diesel car? Sort of half the room. Thank you for buying about 15 kilograms of copper from our industry. You've really helped us and paid my salary. But of course, if you're producing electric taxis, thank you 4 times over, because you've just consumed 70 kilograms of copper to produce a typical car. So the fact that demand is going to go up when all of us switch from petrol and diesel cars to electric vehicles means we're going to need so much more material. In fact, for copper, we will need to produce in the next 30 years more copper than we have produced in all of human history. Just think about that scale. So if you recycled every single piece of copper there is, which we should, no question about it, we would still need to double copper production between now and 2050. So I want to be completely clear with you. We absolutely support a circular economy. We should recycle and reuse as much as we possibly can. Even after having done that, we're going to have to grow mineral production exponentially.
Thank you, Rohitesh. Thomas, did you want to come in on that?
The copper thing is an interesting one because there's almost no material where recycling makes more sense, as the indirect resource footprint of copper is one of the highest of them all. You need hundreds of times of rock to be removed to get the copper out compared to other resources. And this is why a recycling rate that we are currently achieving of roughly 50% secondary copper in our products is so important. Yep. But copper has another side. Mm-hmm. It contaminates aluminum and steel residue when vehicles get shredded. Yep. And copper contamination means loss of corrosion resistance. So one of the biggest challenges that we are facing in getting enough secondary steel and aluminum is getting the copper out. Mm-hmm. And let me be very clear, we have shown with a vehicle we built 2 years ago that you can make a car without any primary resources. Yep. The problem is not technology, the problem is availability, volume, quality and price of secondary material. Mm-hmm. And therefore, technology-wise, it is decisive to get better sorting, better separating of materials, better designing of future cars to support a better separation of the stuff that it is made of.
Great, thank you. I'd just like to build up on the first question a little bit now, in terms of the feasibility of decarbonization at scale. Where are we at? What are the key challenges there? Is it a question of economic viability? Is it a technological readiness and compatibility? Is it a market acceptance question? What is the question? What is the key challenge here? And if I can start with you, Philippa.
It's only there's one answer really. I think it's a mixture really. That there's a lot of challenges, and I know we've just talked about circularity here, but I think there's also that piece around the materials, is that it doesn't necessarily have to go back into the same sector. And actually understanding that one sector's feedstock is another sector's waste, and how we map that as we go through the process, and that's a big challenge for designers, I think, going through, and better engagement across the sectors actually. I think also there's that piece around a lot of the recycling capability at the moment isn't economically viable, so people won't be sure, won't be investing in it. Likewise, what is the right amount of recycled content within some of the metals? How do we use it? A lot of the OEMs feel uncomfortable as you change the recycled content to, say, their aluminium, so it's not got that primary side of it in. So actually, how do you change that? And again, that's a project we've got with Constellium, who are looking at that to have those acceptable levels. So this is a changing landscape for companies, both from which materials do they use to design their products, how do they access those materials, who in the consortium do they trust, and that viability, but how does that flow down the supply chain? And one of the challenges that we really have at the moment is a commonality of a framework. No one has a common set of guidelines and principles that we work to, and that's something that we're trying to do in the UK. There's an automotive council, net zero manufacturing and supply chain piece, to look at that end-to-end process of how do we transition everything, because ultimately the engineers need to have confidence in the products that they're designing and the materials they're using to make sure that they have a product at the end that will sell and that can be produced, that's reliable and at volume. And at the moment, that lack of confidence in some of those materials and that selection of what materials is best is impacting, and knowing that if they select a particular, say, battery technology solution here, that will impact on the structural materials that are used due to the increase in weight. And so that whole system piece is starting to have an implication on how businesses operate and actually changing those business models.
Great. Chris, did you want to come in on that?
Yeah, I mean, as I sort of mentioned already, that it's designing that solution in at the outset to a long life cycle of products. When I think about the TX, and we designed in an aluminium bonded structure in the way that we would deliver our product, that for us gives a lot of benefits. It's lightweight technology, it's adaptable, it gives us 65% reduced CO2 equivalent emissions over the equivalent products on a global average. But those aren't decisions that you can change during the product's life cycle. You fix it up front, you create the activities, and then you move it with it. So I think, there's a responsibility in the early stages of having the right partners for your future product strategy, considering what the recyclable content would be. But then it comes into all of the factors around the economic reality of how you deliver that and where the supply chains exist to deliver that with the right certainty to meet all of the regulatory standards that we operate in to give safe products to the customer that they can afford.
And consistency of product.
Consistency in everything,
Consistency of framework, absolutely. Moving on to a slightly different topic, but talking about the measurement of the decarbonization of the supply chain, are we actually very clear on what the primary source of emissions are within the transport supply chain that may be potentially difficult to quantify? And do we have all the relevant data to measure, for example, Scope 3 emissions? And if I can go maybe to you, Thomas.
Well, that's a big one. I mean, everybody at the moment works based on publicly available average data. So you break down the vehicle into its different kinds of materials, and then you allocate the data that is accepted out there to that material. But very clearly, every piece of innovation, every measure to reduce will only become effective as soon as it has trickled down into the average, which is not right. So this is why wherever we have primary data, wherever we have a contract with our suppliers, and it's more than 500 in the meantime, who, for example, have signed up to the exclusive use of renewable energies, you would correct the number by the primary data that you have. Is this perfect? Certainly not. This is why we, together with a number of other companies, have initiated what is called Catena X. Catena is Greek for chain, which is targeting to have a digital shared infrastructure based on which you can actually add up the CO2 footprints from every point in the chain where they occur, and at the end of the day have a correct sum for the finished product. This is easily said, very hard to be done, and it requires, among other factors, an agreed rule book of measuring and accounting. And carbon accounting is a big thing that is ahead of us, and where a digital infrastructure, agreed rules for allocation of emissions, and their reporting is needed.
And just quickly building up on that then, where do you set the boundaries for your Scope 3 emissions?
Well, we go back to the hole that somebody is digging in order to get the stuff out. So it's
So truly end to
very
end.
simple. Yeah.
Great,
And on
thank
that
you.
one, Wolfgang, we are very clear on this issue. And to be honest, it puts us different to the oil and gas industry, which has perhaps for some time been less clear that they are also committed to managing their Scope 3 impacts. But for us, we have 25 companies in our group at ICMM. 22 already publish Scope 3 data. The 3 that do not will be doing so by the end of this year. So there can be no question that for a third of the mining industry, Scope 3 data is almost already available in all cases, but will be by the end of this year. And then we're going to move into a place of setting targets around reducing Scope 3 emissions. So data should not be a problem from our end of the value chain, but Thomas makes a great point about making sure that there is consistency and standardization in data. So anybody who's worked with Scope 3 numbers will know there are 15 categories of Scope 3 emissions. You can choose to report on some or all of them. But unless everybody is doing that consistently, the numbers you get aren't comparable. What if I don't choose 8 of those categories? Then you can't compare my data to another supplier's data. So when we are going to be issuing guidance for the mining industry that says all miners should be measuring Scope 3 this way, so that when it gets to you folks, you can clearly interrogate that and you know that you're dealing with apples and not apples and oranges.
And can I just build up on that? How do we ensure the integrity of that data, obviously, given some recent events a few years back, how do we actually ensure that the right data gets captured and to allow others, more the consumers, to make those right decisions?
I mean, if I think about some of the operations that I've witnessed within the Geely Group that owns and operates LEVC, I've had the privilege of seeing a 4.0 5G factory but to your point, they've set their own standards on the supply chain. They monitor it themselves. They've created their own sort of way of collaborating and standardizing the information, which, for me, the technology is there to deliver it. It's about adopting it against clear standards and then bringing that in that monitors the supply chain, monitors the use of the machinery and the equipment, finds efficiencies in the way that it's delivered. How you then find the end user's sort of contribution is again more subjective and open to market data that is averaged out and isn't necessarily there without geofencing and telematics that feed back.
And it just to add on that, because it is a massive issue, because the OEMs, 80% of their emissions come from the supply chain.
Yeah.
And actually, a lot of those are small businesses, and actually how do they get the right tools in place? It's great when you're Geely and you've got, the infrastructure there to do all that monitoring. And even, a lot of the manufacturers have obviously measure the energy use of their equipment, but what does that mean for the supply chain? What does that mean for the small businesses? What tools should they be using? How do they develop their processes? And again, something we are seeing more with the OEMs working with their supply chain to start to implement some of that processes. But until there is that common data book, if you like, or common guidance on tolerances and how we're going to measure it, what scope of 3 we're going to look at, and what is going to be accountable for the auto sector, we aren't going to get there. And it's going to, unfortunately, cause problems, further down to some of those SMEs.
And how do you get to the point where you can transparently demonstrate then this emissions challenge of the supply chain? How can you say, Roitesh, you were saying you have the right data in place, and that's great, but how do you demonstrate that in a transparent manner to all those who need to have access to it, like OEMs and others?
Well, what we do on the target setting level first is to have a CO2 target for each and every model that we make. So there is a ton of CO2 budget, if you like, for the supply chain. And then we seek to get there with measures which then are permanently fed into our internal monitoring and control systems. So what we try to do is, on the one hand, steer with the very same mechanism, target achievement and into the supply contracts that our colleagues are concluding with their partners. And on the other side, reporting it back consistently so that we are able to disseminate a figure for the company's footprint and for the product's footprint.
Yeah. And perhaps just putting a slightly different slant on all of these questions, should we only consider carbon emissions in all of this? Because obviously you could potentially reduce your carbon emissions to zero, but inadvertently create an ecological disaster or some, chemical pollution. How is that being captured as part of all these conversations and all this data collection? And maybe, do you want to go take that one, Roitesh?
Absolutely. It would be so stupid of us to optimize only for CO2. Of course, reducing CO2 is the great challenge of our time. But if that was to come at the expense of other challenges like the destruction of nature, like the violation of human rights, like pollution of water, I mean, that would be a crazy bad thing for us to do. And we have to be able to balance these various perspectives and then align on what the best, most responsible source of supply is. So there are many parts of the world where you can produce minerals, and let me just talk about my end of the supply chain, others will have their own view on it. You can produce minerals using zero carbon electricity. So right now, for example, Vale, one of the world's largest producers of iron ore, has zero scope 2. You can produce iron ore with zero scope 2. You can do it in a way that is contributing to a nature-positive future and where people benefit. But let me also be the first person to tell you that the mining industry hasn't always done it that way. We could say, yes, we've decarbonized, but frankly, our record on human rights or on environmental issues has not been perfect. And I think there is a danger here that if we put carbon as the most important factor at the expense of others, you could imagine some people saying, look, just give me low carbon metal. I don't care if you used really dodgy practices to produce it. I just want low carbon metal. Yeah. Let's avoid ever going into that space.
Yeah. And perhaps building up on that, then, what's the role of car manufacturing in a just transition? How do you define responsible raw material extraction in the global south for people and the planet?
Well, I mean, there are two facets to that. First of all, the reason why we have such a strong strategic focus on circular economy is because primary material consumption is a proxy for very many environmental issues associated with the material as such. Secondly, circularity mitigates risks. It mitigates cost risks, it mitigates geopolitical risks in primary supply. It also mitigates economic risk at the end of the day. So circularity makes sense way beyond the CO2 dimension. And very clearly, and also looking at what the legislation in Germany, for example, or in the European Union or the United Kingdom expects from us, we need to be able to demonstrate that we do our utmost in mitigating risks when it comes to environmental standards and human rights standards. Yeah. So the BMW supply chain has 5,000 direct and 30,000 indirect supplier locations. You cannot monitor all of them 24/7. So what you need to have in place is a tiered risk management and risk mitigation mechanism where you address riskier parts of your supply chain with much more effort than the less risky ones, where you are able to respond to issues that come up properly. And a lot of more things that you can do in order to at least make it much less likely that things go wrong.
Great.
Can I just come in? So sorry, just to pick up on the CO2 piece, because I think, and building on what the gentlemen have said, in the fact that, sustainability is a three-pronged area. You have the environmental, the economic and the societal aspect, and you need to be thinking of your decisions around all of those three areas. Yeah. But also one of the big challenges at the moment is we become obsessed with air pollution, but we also need to make sure going forward we're thinking about, the water pollution and also the pollution to the land. And actually, as we shift in terms of our type of technology, so the shift towards electric vehicles, we're seeing more of the ultrafine particles being produced from the tyres and the brakes. So we need to think more about what we're doing there. So actually just focusing on CO2 is definitely the wrong thing to do, because actually you've got to look at the entire system of damage that potentially we're doing or we are responsible for as engineers and as manufacturers, and actually what that's doing to our air, our land and our sea, and therefore, the impact on society for that.
So taking a much more systems thinking type of approach of, integrated systems thinking approach. Chris?
For me, it is that sort of core message of responsible sourcing, and this early stage partnering is crucial to everything you do. you can't just look at carbon, you know, you can't just look at water footprints is an area that I'm always interested in understanding how that operates within the cycle. It's building that sort of understanding of what you expect in your supply chain, what you expect in your products, and ultimately what I'd expect anyone as a customer to be asking their providers of goods of not just how is the sort of the tailpipe emissions of your vehicle, but what is the business model that you operate in that delivers me this product? What is the entire sort of supply chain strategy, your input within the environment that you work within, your sort of weighted assessment against all of the risks that come with this? Because you can make gains on one area at massive sacrifices, and it is a constantly difficult balance that has to be reached.
Great, thank you. Moving on to the other side, to the end of life. Question from the audience. Are OEMs and others seriously considering new business models to enable the circular economy to take more responsibility for the end of life of vehicles? Do you want to take that one, Thomas?
Well, so far, and I'm simplifying now, the things look like that. We purchase components and material. Our suppliers supply from their suppliers, and somewhere at the end are your members. We put the thing together, we sell it, it gets used for 15, 20 years, and when somebody wants to get rid of it, there is somebody who gives them £100, and then it gets scrapped. Today, our job is to make sure that almost all of the car can be recycled by somebody.
Yeah.
And that means our job is done. We never see any of our cars again. We are obliged to take them all back if somebody gives them to us, but people don't. This will change.
Yeah.
An electric vehicle has a value proposition in it, which is way higher than a scrapped car today.
Yeah.
The likelihood of an electric vehicle, and a third of the European cars do that, disappearing outside the European Union, to Africa, to Eastern Europe, is way less likely. On the other hand, we have a keen interest in getting the secondary material back into our supply chain.
Yeah.
So to take the example, in China, we have contractually agreed, as the first manufacturer, by the way, a complete closed loop, making sure that every piece of a car battery that gets back into our organization is fed back to the battery manufacturer. So this is going to be a changing landscape, but not in the next 2 or 3 or 4 years. The ramp up of electrification will mean that the volume kicking in is still some time ahead. And then we are going to face different economics in a different industrial structure. Recycling of batteries is not a small scale business thing.
Yeah.
It means big scale operations. We are dependent on partners in the dismantling and recycling business with a much higher technology competence than what we have today, for example, when it is about separating materials better.
Yeah.
We must not only think of closing the loop within the car industry. What we are doing together with the APC, for example, on aluminum, includes looking beyond our industry.
Yeah.
So the wheels that you can get from Mini, which are 70% recycled aluminum, may not have been wheels, but beverage cans.
Yeah.
So it's also looking at a cross-sectoral supply of materials.
Okay, great. Chris, did you want to come in?
Yeah,
on
no,
that?
I think for us, you know, we spend a lot of time and effort working with education institutes and innovators to sort of look at those reuse, repurposing activities around the battery life cycle, recognizing that, you know, in my view, without those heavy industry developments starting now for how we repurpose these batteries, we run into another sort of plastic generation with batteries, where in another sort of 5-10 years we will have millions of electric vehicles on the road looking for replacement of their batteries and not really having the infrastructure there to manage it. So there's an early stage activity we can be doing now to mitigate and prevent that. And as an OEM, we are, as you say, we have obligations within that, but more than anything, it's about understanding that full sort of life cycle and chain of our products, making sure that we develop those recycling, reuse, remanufacture operations, and find those efficiencies, because it's just the next problem in 15 years' time that will be hitting us very hard if we don't think now.
Right, Ritesh.
Wolfgang, we've seen really good partnerships actually with some of the car companies and the miners to make sure that recycling is incentivized and actually contracted. So sorry, Thomas, to use your competitor as an example here, but Porsche has entered into a partnership with one of the companies in our group, Hydro, to make sure that the aluminium going into Porsche vehicles is at least 60% post-consumer recycled scrap. General Motors has partnered with Vale to produce the lowest carbon nickel from Indonesia. So sometimes from our end of the value chain, we look at it and we say, can we be sure that actually, one, there'll be a demand for this, and two, that there'll be a price premium where there needs to be a price premium? And a signal from the car makers to our end of the value chain to say, yes, we're prepared, let's do a strategic partnership together, often can get the supply chain going faster than if we weren't sure who's going to take this product at the end.
Thank you. Philippa, any other additional thoughts?
Just to add on that, I mean, I think the other thing is when we recently did a business critical looking at some of this, and we did a battery recycling value chain before we'd done it in the manufacturing side of it, and where the value was. And actually what you start to see is, once the batteries have actually been made, is actually, their purposeful life is maybe much longer than the use within the vehicles. And actually, one of the things that we've done, and again, in that Recovers project that I touched on, a company, Autocraft, has found that from all the recycled batteries that it's looked at, only actually 1.4% of them have gone to full recycling. The rest actually have either had a couple of packs replaced or cells replaced and actually been refurbed and almost go back in. Because the battery monitoring systems that, the OEMs are putting into place now, and the understanding of how those battery systems are being used in the vehicles during their life is exceptional. There's real-time monitoring, that performance data is great. So really understanding how the health is of each of those elements within the battery, so how all the raw materials mean that actually you're extending that life, or you're understanding the different routes to market. So again, that goes to those waste streams that I talked about earlier. But actually, there's some really positive data that actually, how do we understand and get better information and use that data to take products forward, so we don't have to just replace when we think it's necessary, but replace when it's actually necessary.
Great, thank you. So building a little bit up on the topic of collaboration, obviously, we've heard there's already a lot of collaboration going on across the entire supply chain. Is there anything that we could do differently to accelerate decarbonization of the supply chain? Maybe if I start with you, Ritesh.
Car companies could run mines. That would help. I say that only half jokingly, because actually what would really help on the collaboration side is if downstream users, both battery manufacturers as well as the OEMs at the end of the day, lent in to the sort of mining value chain side of things a little bit more, not only to enhance the kind of collaboration I've just been talking about, but actually there's some really good technology transfer that can happen. One thing that we really still struggle with in our industry is how to make sure that people stay safe as we are mining for these commodities. It is a very sad reality that even today people get hurt or die in the mining operations. Yeah. And we're obviously doing everything we can to prevent that from happening, but who knows more about keeping people safe than the car industry? And if we can learn more from them around health and safety and making sure that we are making our mining operations as safe as possible, that actually does really move things along. So I suppose in one sort of snippet, I would say, embrace your inner miner, car companies, sort of join us in that end of the value chain.
Great. Thank you, Philippa.
So transparency of data, I think, is a big one across the OEMs. I'm not sure we'll get them owning the mines, but I think sharing the information that they have is one thing. But also, I think, we're in a global shift, and actually what you're seeing and what we see, we have an accelerator program, is a lot of the spin-outs and startups within universities or small businesses. And Ops Delivers are over there from the innovation side of it, but you're seeing a number of these new companies where you're seeing great innovation and actually making sure that they are being picked up by some of the OEMs to demonstrate some of that technology to accelerate them to market and for growth. is actually a really important part of it. So actually, you know, and a shameless plug here, we have our advanced route to market demonstrator program currently open. And last time we ran that was a COVID call, but it saw a number of small startup businesses partner with the OEMs and actually pull through and accelerate some of these net zero technologies to market sooner. And actually that's a great opportunity because the UK is known for its innovation, and actually looking at how we can accelerate this much faster is a key aspect of this.
Great. I'd like to end on some final thoughts, some final question. If you had one symbolic pound, what would you invest it in to accelerate the decarbonization of the supply chain? If I go all the way from Reuters to Philippa.
You're going to say, of course you're going to say this, but if I had one symbolic pound, I would put the entire pound to growing copper supply. And the reason for that is that copper is essential to decarbonizing everything, and we don't have enough of it. And I don't think we as a world have understood how short we are on copper supply. Cars are going to be competing with wind turbines for copper, and the last thing we need is that we don't get to net zero because we don't have enough copper. So I would put that entire pound into building more copper mines.
Great. Thank you, Chris.
For myself, it would probably be building on the last point about that innovator and startup activity within within universities, and that sort of investment for me would be going into the industrialization of some of those technologies, you know, here in the UK, and how we build on that. Because I think there's a great amount of work that goes on. There's some great technology that finds efficiencies in the optimization of batteries, in processes, in energy consumption. What we need is that growth of that into the industrialized sort of strategy of organizations. And I think that's where there's an investment needed for me.
Thank you, Chris. Thomas?
I would go for high performance digital accounting and measurement of CO2, which is urgently needed. I mean, we started accounting with pounds and euros and dollars in the 14th century. We are starting with carbon accounting just now. So that's a job that needs getting done pretty soon and
Great.
faster than 600 years.
Thank you. Philippa?
I'd agree for a agreed global common data set that was transparent, so everybody had access to agreed measurements of the different materials that we're using, where they were coming from, but that was accessible to all sizes of organizations, not just the ones that could afford it.
Great. Well, thank you very much all. Philippa, Thomas, Chris and Reuters, thank you for all your insights, and I hope it leads to new conversations and new collaborations. Really focus on accelerating further our decarbonization of the supply chain. So thanks very much all.
Thank
you.
you.